Okay, now the final component. I'll just be going through two questions and then doing a quick summary of this chapter. So now let's take a look at this question. Um, oops. Yeah, so you're given all these details, and the first part is they ask you to find the value of h. Yeah, I know that if you draw like a straight line, right, from center to any point, this is equals to 15 cm, which is the radius. Okay, so yeah, just note this, and then so let's say if you have a straight line down here, horizontally down, sorry, uh, vertically down, so this would be 15 cm, and then you can use Pythagoras theorem. So you need to cut the triangle. So this would be a right angle triangle. This would be O, this would be A, and this would be X. So this is just a vertical line down from O, okay? And then your AX is basically half of AB, which is equals to 11 cm. And then this is given to be 15 cm. So you can find your OX from here using Pythagoras. So it's just 15 square minus 11 square, square root of this. Okay? So once you find your OX, your value of H is basically is equals to 15 minus OX. OX, okay? So that's your part 1. Then your part 2, they ask you to find the area of cross-sectional area, which contains the water, which is basically your this. So you see, this is basically where your segment comes in. Okay, I'm just gonna erase this part. This is your minor segment. Remember we went through this earlier? So yeah. So this is your minor segment, and yeah. So they are asking you to find this area. So your first step is you should find you should find the angle AOB, okay? So remember previously we drew this triangle. So you need to find this angle theta, and then so you can use trigo identities. So in this case, sine theta equals to 11 over 15. So you can find theta. So once you find this, angle AOB is basically equals to 2 theta. Okay. So yeah, you got this value, and then you can find the area of the sector. Okay. So yeah. Oh yeah, by the way, just note that for this kind of question, right? Because the question doesn't tell you what's the unit uh for the angle. So you can do it either in radians or you can do it in degrees. But your final answer will still be the same, okay? Because the final answer is area, it's not your angle, okay? So just take note of this. So once you find your angle, you can find the area of a segment, which is uh if I'm doing in radians, it will be half r square theta, half times r square, which is 15 square times theta, which is angle AOB. Okay, so A1, let this be A1. But if I'm doing in degree, it will be your theta over 360 times pi r square. Okay, so theta in radians, theta in degree. Okay, so yeah, Once you find this area, you have your area of your minor sector AOB. Then you need to minus off your area of triangle, which is uh, triangle AOB. Okay. So again, you have this triangle here. Let me redraw. You have AOX, AOX, 15, 11, and then your OX is previously calculated already. So this is your height 2, okay, since there's already a height here. So once you find this height, your triangle AOB is basically half times base area 22 times height 2. And then your area is basically equals to the A1 minus area of AOB. So this would give you a final answer. Okay. All the working has been written down already. Just type the answer in the calculator and you'll get the final answer. Okay? Okay, yeah, that's it for this question. Now we are back to this diagram. Okay? So as I said, this is a very common diagram you will see in this chapter. So the first part they ask you to find the value of theta. So again, it's the same concept. Extend this and then this is 90 degrees. This is 2 cm. So let this be x. So redraw the triangle. X, Q, P. Then PQ is your two radius, sum of two radius, which is 8 cm. This is 2 cm, 90 degrees. Yeah, you find this angle first, theta 1. And then once you find theta 1, your value of theta is basically equals to 90 minus theta 1. Okay? So that's your part 1. And then your part 2 is find the area of both the sectors. And yeah. So to find the area of the sector is just if your theta is given to be in radians. So is area 1 equals to half phi half times y squared times theta. Then let this angle be theta 2, okay? So your theta 2 is basically equals to 180 minus theta 1, remember? So in radians it will be pi minus theta, okay? So your area 2 equals to half times 3 squared times pi minus theta, okay? So once you find area 1 and 2, again, is area of trapezium minus A1 minus A2, okay? This question is very similar to the one that we have done previously, so take a look at it if you don't understand this one, okay? So your area of trapezium, remember you need to calculate AB. So your AB is actually the same as PX equals to PX. So we have already drawn this triangle. So use Pythagoras theorem to find your PX. It's just 8 square minus 2 square. Okay? Yeah. So yeah. So this is half times AB times your sum of your parallel lines, which is 5 plus 3 equals to 8. Okay, that's it for this chapter. So this marks the end. So I'll do a quick summary. So um your formula for length of arc is equals to theta over 360 times 2 pi r. So this is your circumference of a circle. Then your area is basically the same thing, theta over 360 times pi r square. And if you do the same thing in radians, this one is just r theta, and this one is half r squared theta. Okay, and when changing between degrees and radians, just note that uh, 180 degrees is actually equals to pi, and so from this pi radian, so you can also get 1 radian is equals to 180 over pi. So you just need to know these two formulas. Is it? Yeah. The second formula is just a manipulation of the first one. Okay. Yep, that marks the end of this chapter. So if you have any questions, do let me know. Thank you for watching.